Okay, in this example one, I've got to express this in partial fractions. Now what that means is we take a complicated fraction, in this case it's got a quadratic denominator, which I'm going to be able to factorise, and I'm going to split it into two fractions using the two factors in the factorised denominators as the separate denominators for these fractions. And you can see how this might work, because if I was adding this fraction to this one, my first step would be to combine them over a single denominator, and that's quite likely to be this denominator here. So we're just going backwards from the combined fractions added together to separate them out into the original fractions. So my first task here is to make it look more like this. In other words, I've got to factorise the denominator. So it's going to be 7x minus 8 over, I know it's 2x squared minus 5x plus 2, but that's going to go into two brackets. So 7x minus 8 on the top, and I'm going to need a 2x, and I'm going to need an x. And then how am I going to make this plus 2? I reckon it's going to be a minus 1 here and a minus 2 there. Yes, if you check that, then it does multiply out correctly. And this pattern and AQA can be very helpful in terms of telling you what to expect, but the general pattern is that we just use each, if we've just got separate factors in the denominator, we just use each one once as the denominator of one of the separate fractions. So 2x minus 1 plus b over x minus 2. So that's my starting point. Okay, I've written it up here because I think I might be a little bit short of space below. So how do we go from this? This is my starting point. I now need to find out what a and b are. Well, the first thing I need to do is to make it look more friendly by getting rid of all of the fractions. So I can see that this will just turn into an a if I multiply by 2x minus 1. And multiplying this by 2x minus 1 will make this factor disappear from the denominator. Now the smart thing to do is to multiply by that bracket, but also by this bracket. So what I'm going to do is multiply by both brackets in the denominator of this fraction. So I'm going to end up with 7x minus 8. Alright, so I've multiplied by both brackets. Now what will happen to this term when I multiply by both brackets? Well, multiplying by the first bracket, the 2x minus 1, will just make this 2x minus 1 disappear, which would be a. But I'm not done, because I've got to multiply by the x minus 2 bracket as well, so I get a times x minus 2. I've now multiplied this by both things. One had the effect of making the bottom disappear, and the other has appeared on the top. And then when I take the second term, this time multiplying by the second bracket, the x minus 2 is going to make the bottom disappear to leave me with b, but then I might need to multiply by the first bracket, 2x minus 1. So this is beginning to look simpler. So I've got 7x minus 8 has got to agree with this. And in fact, I can put in both of these, I can put the third line in. These have got to be identities. In other words, they're not just true for some single value of x that I can find. They have got to be true for every single value of x. This has got to be equivalent in algebra to this once I've got the correct values of a and b. And that means the smart thing to do now is to start substituting in clever values of x. So what's a smart value of x? It's something that will make this look simpler, so I can find either a or b. And I can see that I can make this term vanish, we'll see what that means in a minute, by taking x to equal 2. Okay, the idea is that if x equals 2, then this bracket is 0, and a times 0 is going to be 0. So when I do that, I'm going to get 7 times 2. So 7 times 2 minus 8, okay, is going to equal a times 0, 0a, plus, and then x is going to be 2 here, so it's 2 times 2, which is 4, minus 1, that's 3b. So, simplifying, 7 times 2 is 14, minus 8 is 6. So this means that 6 equals 3b, and lo and behold, b is 2. And then I've got to do the same thing to find a, or I can do the same thing to find a. So what's the smart x for this bracket here? Well, 2x minus 1, for that to equal 0, x has to equal a half. Okay, so substituting x is a half throughout the whole equation. 7 times a half is 7 over 2, minus 8, okay, is going to equal a times, okay, a half minus 2 is minus 3 over 2, plus, and the whole point was to make this 0b. So this vanishes, so I've got 7 over 2 minus 8, well 8 is 16 over 2, so 7 minus 16 is minus 9 over 2, equals minus 3 over 2a. And the minuses cancel, the halves cancel, divide both sides by 3, and this tells me that a equals 3. So I can now write down the answer, which is that 7x minus 8 equals, over 2x squared minus 5x plus 2 equals a, which was 3, over 2x minus 1. I'm just going back to my starting point here and putting in the values of a and b, which is very simple to do, but if you don't do this, then you don't deserve all the marks. We actually have to arrive at the correct partial fractions, which are these, and that's that example finished. So I hope that makes some kind of sense.